Good afternoon, everybody. I will present you with my master thesis research on the reconstruction of the seismic history of Aysén Fjord in South Chile by using seismic stratigraphy and sediment core analysis. So this research is based on the occurrence of mass transport deposits. These are landslides and rockfall events which can enter into a basin such as a fjord and leave a sedimentary imprint on the bottom of the basin. As I said, there are different types and the morphological variety is really wide, and also sometimes there are turbidites or megaturbidites associated with these deposits. Now what's important is if you want to reconstruct the seismic history is that these mass transport deposits have to be earthquake triggered. And how do we know this? We applied synchronicity criterion, meaning that if several mass transport deposits are observed in several locations, but at the same time, they are most likely triggered by an earthquake. So for a paleoseismological reconstruction, most of the time we use two main data methods. That's the seismic lines and one or more long sediment cores. And in a sediment core, we usually see a peak in density or magnetic susceptibility when there is a mass transport deposit. While in the seismic facies, we usually see chaotic or transparent lenses appearing in between the normal sedimentation. So I studied Aysén Fjord in southern Chile, the Patagonian Fjordland. It's surrounded by the subduction zone from the Chilean subduction zone and the Likini-Ovki fault zone, which is also cross-cutting the fjord and is the main reason for earthquakes in the region. One of the earthquakes in 2007 the epicenter was located directly in the fjord, it's indicated with the red star, and there were a lot of different landslides that were observed at the time of the earthquakes, which you can see in blue, which was studied during a previous study, also based on seismic lines, so showing that Aysén Fjord is a good potential recorder of earthquakes. So what I did then, firstly, is looking at all the different seismic lines that were in the and that were taken. This is one example on which you can see the color levels are different levels on which mass transport deposits are present. In total, I found 11 of those, and the blue one on top is the one resulting from the 2007 earthquake. So if I map this over the entire fjord, I can make distribution maps over the entire fjord. So for each event, there are several different landslides over the entire fjord, so this means that the synchronicity criterion applies, and we can assume they are all earthquake triggered. Now, if we want to reconstruct a seismic history, we of course want to know how old all of these events are. So we try to correlate the seismic data to a sediment core, which we can date by radiocarbon dating. We have a long sediment core of 21 meters, in which several different layers are present, and we measured density, acoustic impedance, and magnetic susceptibility on the core, and each change in acoustic impedance corresponds to a change in the seismic profiles, so high reflection amplitude, and we can link these seismic lines with the core in this way. So if we know which line from the seismic data corresponds to which layer in the core, and we have an age-depth model, we can try and find out what the age is of each layer, and we can make age distributions, which you can see on the bottom. As extra way of validating the age-depth model, we looked also at tephra layers that are present in the core from historical eruptions in the area. They were dated accurately on other cores and other different methods, and all of the tephra layers correspond really nicely to the literature ages of these historical eruptions. So this means that we can assume that our age-depth model is quite correct, and the seismic history we construct is also really good. So the left table shows for each of the events the age, and in total this means there are 11 events, of which at least 6 are pre-Holocene, and also 4 major eruptions. So as a conclusion, what this research proves is that fjords have a high geological value for both paleoseismological reconstructions, but also for tephra chronology, because you can easily find the different tephra layers from the major historical eruptions. And we constructed the seismic history of the Aysén region meaning that we have one earthquake more or less once every 2,000 years, with at least 6 during the Holocene. Thank you for your attention.